Hi there, my name is Hannah Gannon, and today I'm going to be talking about a few different types of strokes and what causes strokes, and also a treatment method for a specific type of stroke as well. I have a presentation which is going to kind of aid my explanation of things, and I do apologize. I did try to record this earlier and record myself as well as my screen, and it didn't work out too well, so I'll have to go with this method for the time being. So hopefully you can kind of see it, but I wanted to start off first by going just briefly over what a stroke is in general terms. So a stroke can be described as something that results in the blood flow being interrupted to the brain, and as a result the brain cells are not able to get enough nutrients and oxygen, and they can actually potentially die, and that tissue can um, yeah, just be deprived of oxygen for too long, and as a result die. Some risk factors for strokes include being obese or physically inactive, as well as heavy drinking or smoking cigarettes, or having high cholesterol or high blood pressure, as well as many other things. So there are a lot of risk factors going into increasing the likelihood of having a stroke. Something that I did find really interesting was that COVID-19 is actually considered a risk factor, or potentially a risk factor, for stroke as well. Obviously, it's still pretty early to say that this is something for sure, but there is a lot of research looking into this being a risk factor for strokes. So I did just want to mention that. So the first thing that I'm going to go over is a specific type of stroke called a hemorrhagic stroke. So this specifically is defined as a rupture of a blood vessel. And so this can be caused by a number of things. A few things that can lead to this are uncontrolled high blood pressure, overtreatment with blood thinners, as well as an aneurysm, which is kind of when the wall of an artery becomes weakened. And so it's just that weakened area of that artery or blood vessel. Another risk factor for hemorrhagic stroke includes trauma, as well as an arteriovenous malformation. Now, this risk factor is a little less common, but it is when you have an abnormal tangle of thin-walled blood vessels, and this thin-walled blood, this tangle of these blood vessels actually ruptures, and so that's what leads to that risk factor. Next, I'm going to go into what is called an ischemic stroke, which is another type of stroke. Now, this accounts for about 87% of the strokes, so it definitely is a little bit more common, but this specifically results in a blockage of a blood vessel, and hence not being able to deliver that blood supply to the brain. And so the main cause of this is atherosclerosis, which is when there's fatty deposits or cholesterol along the blood vessels, and this is just going to kind of narrow the vessels, and therefore have less room for that blood to flow through, and then lead to potentially blood clots. So there's two different types of obstructions specifically for ischemic strokes. The first one is a cerebral thrombosis, which is what I was kind of discussing earlier. It includes the fatty plaque within the blood vessels. Next, there's something called a cerebral embolism. Now this is a little bit different because it's a clot that usually forms in either a larger artery or the heart. And what's interesting about this is that it actually breaks off, and it travels. So that's the key, is that this is actually a clot that's going to travel, and it's going to go to a smaller blood vessel, and that's where the clot a lot of times happens, is when it gets to that smaller blood vessel, and and the vessel's too small to travel through, so then hence it creates a clot in the end. So next we're going to jump into TPA, which is actually a treatment for a specific type of stroke. It is a clot dissolving medicine. That's how it works, is that it dissolves clots. It was actually one of the first FDA approved treatment methods for acute ischemic strokes, and it is usually administered through an IV in the arm, and it is really it's definitely ideal to administer this medication early. So they kind of aim for at least 3 hours between the moment that they kind of started noticing the onset of the stroke. You want to try to get it in those first 3 hours. That's really something that's crucial, just to kind of help limit the amount of brain damage, and the amount of cells that are really deprived of oxygen. So because TPA is a blood thinner, it is not used for hemorrhagic strokes or head trauma. It is specifically used for acute ischemic stroke. So that is something that I did want to mention. So what is TPA and how does it work? So TPA is actually a protein, and as we know, proteins are made of amino acids. So this protein is going to be made of 527 amino acids, and it actually has 5 different domains. It has a protease domain, an epidermal growth factor domain, a finger domain, and then 2 cringal domains. The particular domain that I'm going to focus on, though, is the protease domain. So how does TPA work, and why do we use it for ischemic strokes? So TPA is actually a serine protease, which is a type of enzyme. And as we learned, so this enzyme is actually going to cleave peptide bonds within proteins, and it's found in endothelial cells specifically. Other type of serine proteases include like chymotrypsin and trypsin, which are actually digestive enzymes, and so this is kind of in that same family of enzymes. So because it is an enzyme, and like I said, it's going to cleave those peptide bonds, what TPA does specifically is it converts plasminogen to plasmin. And plasminogen is what we call a zymogen, which is almost like an inactive form of a substance, almost like a precursor to an enzyme. And so the plasminogen is considered the inactive form, and then it's going to be converted through TPA to plasmin, which is going to be that active enzyme. And plasmin is useful because it is a major enzyme and responsible for clot breakdown. And so what plasmin does is once it's activated, it cuts the fibrin mesh, which is part of the blood clot. So it's going to cut that mesh, and then it's going to allow for what the technical name is fibrinolysis. And so as a result, you're able to break the blood clot, and you're able to increase the blood flow to different parts of the brain, hence increase the oxygen supply and nutrients to those cells so that they don't die off because they're not deprived of oxygen and vital nutrients as well. So in summary, I did just want to quick mention that these are some of my resources that I looked at just to get all this information from, and then all my pictures that were in my presentation, the URLs are listed here. And so in summary, there are several different types of strokes. I just went over the hemorrhagic and then the ischemic stroke. One great treatment method for ischemic strokes is called TPA, which acts as an enzyme, and it's going to convert plasminogen, which is an inactive form, to plasmin. And this is going to help break down blood clots, which is going to increase the oxygen supply to different areas of the brain, and hopefully able to salvage as much healthy brain tissue as possible. So this is just one of the great ways that we have, or one of the ways that we can kind of help patients who do encounter symptoms of a stroke. And so I just wanted to kind of mention how I thought that was really cool how when I was going through this how a lot of the things that we learned in class and things I learned in my biochemistry class, how it really plays into treatment methods within the medical community. And I think that that's really fascinating, is just how much what we learn really applies to a lot of the times, like what fields we're interested in. So thank you for listening, and have a wonderful night. Thank you.